So problem 20 is the factorial digit sum. So first of all, it tells you what a factorial actually is. So the way I like to think of a factorial is every number up and including the number, like up to and including the number, all multiplied together. So it gives you the formula here, so like n times by n minus 1 times by n minus 2 times by n minus 3 all the way down to 1. And it gives you the example of 10 factorials, so it's 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. And it gives you the answer, so this huge number. Now it tells you the sum of the digits of that number is obviously 3 plus 6 plus 2 plus 8 plus 8 plus 0 plus 0, which is 27. Now it wants to know the sum of the digits in the number 100 factorial. So I'm not actually sure if there's a factorial function in Python. I guess I should probably look this up. Let's have a quick look. So Python factorial. Yeah, okay, so the math module has a factorial function in. I suppose I could use that, but I'd quite like to code my own, I think. So what we're going to do is we're going to code our own. So define factorial. This is going to take in a number, so we'll call it n. And what we're going to do is we're going to say if n is equal to so we're going to say if it's equal to 0, we're going to return 1 because 0 factorial is 1. If n is equal to 1, return 1, and then we're going to say else. So we want to return n times by and then factorial of n minus 1. Now this is obviously a recursive definition of this. I've covered a recursive function in a previous video, so hopefully this isn't too different to what you've already seen. But if we say like factorial 5, so we print this, and then yeah, so if I print that, run that, okay, so get rid of that colon, don't know why that was there. So we get 120, so this is actually working. If I put this as like 100 now, you'll be able to see, so this is the number that we're going to be summing the digits across. With this being a recursive function as well, normally recursive functions are pretty slow if like they end up branching into like hundreds of different functions, but this one only branches once, so it's like you call factorial, and then the worst case scenario you just have to call factorial once more with a smaller number, and then you call it again with a smaller number and again with a smaller number. The previous recursive function we did had like 2 separate callings of the function in, so it like exponentially grew and the computation time was really slow. Here it's not so bad. So yeah, that works. So what we're going to do here is we're going to define main now, and we're going to say, so the number we're going to do factorial up to, we're going to call it x. So x is 100, so we're going to call factorial on x, and they're then going to return an answer. So we're going to say answer is equal to factorial of x. Now digits is going to equal, so we're going to list the string of the answer, and now if I print out digits and then call main, whoops, okay, so if I do this, you see what it's done. It's done, so up here we got the 100 factorial, that was like, we began with a 9. You see what it's done is it's separated every digit into its own element in a list. So first we converted the answer to a string, and then we converted this string into a list which just separates all the individual elements into their own element in a list. So now once we've got all these elements in the list, we can say the sum, or what is it, that's for the sum of digits. So we could say sum of digits is equal to the sum of, I suppose, digits. Now, does that work? Nope. So what it's going to be is it's going to equal 0, and then we're going to say for digit in digits, sum of digits plus equals, and then we need to convert it back to an int so we can do addition with it. So it's going to equal the int version of digit, and then we want to print the sum of digits. And I'm going to get rid of that print of digits because we don't need to see the huge number anymore. So 648 tells us the answer, and if we go back to over here, we see it's 648. So really quick video, like 5 minutes long, but this question really wasn't too hard, and we've done all like stuff similar to this before, like with lists and separating strings and stuff like that, and recursive functions. So yeah, really simple one. Yeah, leave a like if you liked it, subscribe if you want to see more. Thanks for watching, I'll see you in the next video.